Okay, so here's some more examples. Is my function a relation? Let's grab the pencil. And as I pass the pencil through, look at that. That x value is trying to date some y value on the north side of town and another y value on the south side of town. Not cool. So is this relation a function? No. Okay, this is not a relation. Now, this domain and range doesn't have clear endpoints like the last two values we had because of these little arrows. Now, whenever you have little arrows, you need to realize that those arrows are going both up forever and right forever. That arrow is, and this arrow down here is going right forever and down forever. So when I'm talking about my domain, and I'm going to say how far left can I go, comma, how far right can I go, I need to realize that this truly is going right forever. So how far left can I go? Well, the leftmost point on my graph looks like it's at -5, comma, all my values keep going on forever. Sometimes if you want to take your pencil, it might help to grab your pencil and drag it through. Looks like my first value is at -5. That's the first time my pencil touches the blue. Keep going, yes values, yes values, yes values, yes values, yes values. And those arrows say it keeps going on forever. So what's the way we write forever? Well, is infinity. Infinities always get parentheses. We've talked about that. But the -5, he is not an open circle, it's a closed circle, even though it's not like a big fat closed circle. If there isn't an open circle, it's going to be implied as a closed circle. So he's going to be a bracket. So to get the range, I'm talking how low can I go, comma, how high can I go. Now don't forget we have these arrows here. So even though it looks like my lowest value might be at like -7 or so, it's really not because the arrow keeps telling us it goes forever below. If you want to rotate your pencil, you can drag it from the lowest it can go. It goes down forever. Yes values, yes values, yes values, yes values, up forever. So because it goes down forever and up forever, my range is going to be -infinity, comma, +infinity. Again, because of those arrows. On the next example, we only have one arrow. The other points are endpoints, okay? This arrow right here goes to the right and it goes down forever. That's the first thing I always want to do. When I decide if it's a relation or not, I need to grab my pencil. Make sure you rotate it so it's a vertical line again. As you pass your vertical line through the function, at any one point, does your pencil touch more than one part of the blue line? Well, it doesn't. So this looks like a good function. So is this a function? We will write yes. What's the domain? The domain is how far left I can go, comma, how far right. In this value, as left as I can go, looks like it starts at -5. Now that's an endpoint, and I can include it, so I'm going to keep a bracket on it. How far right can I go? Well, that arrow tells me I'm going to keep going right forever. So that is going to be my domain. It might help if you think about it as you're dragging your pencil. Was the first time going left to right? How low can you go in the blue? The blue graph touches my pencil first at -5, and then it has yes values, yes values, yes values forever. Even though that it looks like it might stop at, I don't know, around 6 or so, it doesn't. It keeps going on forever because that's what the arrow tells you. Now, my range is how low can I go, comma, how high can I go vertically. So how low can I go? Well, my arrow says I go -infinity, as low as possible. That keeps going down forever. How high can I go? Well, here's my question. Am I talking about this point right here, -5, 2, or am I talking about 1, 6? Well, how high can I go? Well, the value here is much higher than it is over here. So we're actually talking the highest point. So the highest point here that my blue value can go looks like 6. That's hard for some students to realize that we're not talking about the leftmost starting point, we're talking about the highest starting point. If you rotate your pencil, you can drag it from the low to the high. How low can you go? Well, that arrow says I go -infinity, comma, how high can I go? The highest point right there is at 6. So using your pencil might help you to see how low you can go, comma, how high you can go. On the next two, we have the same questions. Is the relation a function, yes or no? When I drag my pencil through it, I only hit one blue point at every one time, so the vertical line test tells me that this is, yes, a function. The domain says how far left can I go, comma, how far right can I go. So on this problem, it looks like my leftmost value is at -3, and my rightmost value happens to be at +3. So how low can I go? -3. How high can I go? +3. This is our first example that has an open circle. So the open circle receives a parentheses, whereas the closed circle is going to receive a bracket. So that's the domain. Again, if it helps you to drag your pencil across, you can do that. How low can I go? The first value starts at -3. The last value is at +3. You're looking right here on the x-axis. So for the range, I'm talking how low can I go and how high can I go. So the lowest value I can go on my range, my lowest y value is 4, and the highest y value is 6. Another way you can think about that is to drag your pencil from the bottom. How low can I go? -4 is the first time I touch my blue value, and then 6 is the first time I stop touching my blue value. So from -4 till 6. Now -4 has the parentheses and 6 has the bracket. Okay, so my last problem is an interesting case because it's a vertical line. Is this a function, yes or no? So make sure you rotate your pencil to be a vertical line, and as you're passing through, there's no values here, no values here, no values here. Whoa, right there we have a problem, right? Every x, let's see, was at 4. 4 is trying to date everybody in the world. 4 is trying to date this guy and this one 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 and this one. Is this a function? Absolutely not. That x4, number 4, the value 4, is trying to date everyone. So this is not a function whatsoever. What is the domain? Well, if you pass your pencil, there's no values, no values, no values, no values, no values. Oh, there's a value right there of 4. 4 is trying to date everybody. And then right after 4, no values, no values, no values, no values. So in this case, there's only one value in the domain, and that's 4. Now because it's just a value and not an interval, I am going to use just the braces and just put the one number in there. If I'm just listing a number, it's in braces. If I'm talking about all of the values between two numbers, that's when we would use interval notation. Now this arrow goes down forever and this arrow goes up forever. So my range is -infinity to +infinity. It truly does go down forever and it truly does go up forever. But there's only one value in the domain, and that is 4. So we use interval notation on the range because we're talking about all of the values between, and we use set notation on the domain because it's only one listed value. Now, even if it was more than one value, if it's just a list of values, we use the braces. If it's an interval of value, meaning everything from one endpoint to another, we use interval notation.